Hello, my name is Paul Parkinson, and I'm going to go over developing event-driven auto-compensating Saga transactions for microservices. This is basically the video for a blog that you can find at the locations on the screen here. And I'll be talking predominantly about the Oracle Saga framework in the Oracle database, but also the features that go into that. So let's proceed. Let's first just go over the basics. Traditional systems use XA two-phase commit and protocols like that, but they have tight coupling, which allows them to use the distributed locks involved in these protocols. And in a microservice environment, that may be possible, but it may not due to the introduction of extra network latency and disparate systems and services and such. And so the Saga pattern from that was defined back in 87, 86, has been used more than any other pattern to have a distributed consensus among participants in a business transaction or a potentially long-running action, and not use locks. And therefore, it's not using XA locks, it's using local transactions. Okay. And so that's sort of the short story there. If you look at the flow of a Saga, it's actually quite similar to a JTA or whatever two-phase commit transaction application you've used in the past, where there is a coordinator, like a transaction manager. And an initiator, in this case, we have a transfer service making the classic bank account transfer. The transfer service is starting in a Saga or starting an LRA. So the most popular and well-defined Saga spec is the long-running actions LRA specification from MicroProfile. And so I'll use Saga and LRA interchangeably when I talk. But what will happen in the normal flow is a initiating service, such as this transfer service, starts a Saga and tells the coordinator it wants to start a Saga. So the coordinator starts that. The transfer service then calls other microservices, account 26 or bank A, well, whichever way you want to look at it, and bank B or account 67 in this picture. Those accounts receive the LRA ID, the Saga ID, as it's propagated from the transaction service, and they enlist themselves in that Saga. So they tell the coordinator, "I want to be part of this Saga," and then control comes back to the transfer service. That service decides whether it wants to complete or compensate, essentially commit or rollback, and issues that command to the coordinator. Now, what is different with the Saga specification from JTA and XA is that during the enlist, the account services or bank services that we see here enlisted an endpoint that the coordinator will call. So unlike distributed locking such as XA, the coordinator won't just call the underlying resource managers, that is, to do a commit or rollback. It will call the participant service, and then the service needs to do that complete compensate logic itself. Okay. And this is to avoid, again, those, in doubt locks and to use local transactions. So, of course, the problem is this puts the burden on the application developer to write complete and compensate logic, rollback or commit logic, but it's not as easy as rollback and commit. You need to keep a journal. You need to make sure that you handle failures. If there is a compensate action, failures in the compensate action itself. So extremely complicated. And that's one of the things I'm going to talk about that's addressed with this Oracle database Saga framework. So first thing I want to mention is that the Oracle actually has two Saga Coordinator products, and they have different features, both extremely powerful, but you see with the different features how you may want to use one or the other. So I just want to remove confusion because in all of my Saga blogs, I have talked about both frameworks before, but in my previous Saga blog, I was talking about MicroTX. And in this one, I'm talking about the Oracle Database Saga framework. Okay. So some of the big differences I'll just mention real quickly. And again, this is the way things stand now. There may be, there are features in being developed for both of these, but as it stands, um, MicroTX is deployed in Kubernetes while the Oracle Database Saga is actually right in the database. The MicroTX supports REST, which is in the LRA specification, um, but the Oracle database actually supports messaging. And event-driven microservices, of course, have become very popular, especially when you move closer to the data for scaling, versioning, quality of service, things like that, just event-driven advantages in general. The other thing is this automatic recovery state, and more specifically, the automatic compensating data via lock-free reservations that I'm going to talk about a bit. That's in the database. And then the MicroTX has the additional support for XA and a protocol called try cancel commit. Okay, so moving on, the Oracle Database Saga engine, as I said, supports event-driven communication, and it does so by using the transaction event queues that are in the database. Now, this was previously called advanced queuing, and this has been around for decades. And what's a number of unique features in this messaging engine, but one of them is the fact that it takes advantage of the fact that it is running in the database, and being that being the case, it can actually conduct messaging and data ops in the same local transaction, okay? And that manifests in a number of great benefits, but especially for microservices that are data-driven. So given a quick example of an order inventory service, where an order is placed, that order is persisted in the database, and a message is sent from the order service to the inventory service. The inventory service gets the message, checks the inventory and adjusts it, and then sends a message back to the order service about the inventory status. The order service updates its order in reaction to that, okay? So in that scenario, we see on the left-hand side, if you're using something like Kafka, Mongo, Postgres combination, you need to account for duplicate delivery and make your code idempotent. And in some cases, this actually cannot even be handled on, with this type of architecture. For example, on the inventory side, you're actually doing 3 actions in the same local transaction in the Oracle case, but not if you're not using the Oracle database. So you're doing the receive of the message from order service, adjusting inventory, and then sending a message back to the inventory service. So it's, to account for that in your code, failures at all those different points, you cannot actually do that unless you are able to do them in the same local transaction. And that is what you can do with the Oracle database and TEQ. So it's not only more robust, it allows you to just write your business logic and not worry about, retries and idempotent producers and consumers, etc. So very powerful, and that's what the Saga engine uses in the Oracle database, okay? The other feature that's new in the database that is taken advantage of by the Saga framework is lockless reservations, and using lockless reservations to provide auto-compensating data types. Now, this is a feature that's actually based on the concept of escrow, which was first brought about or conceived in 1985. So the same, many decades ago, around the same time as the Saga, actually before the Saga specification. So it's a well-proven, technique, and it's now in the Oracle database. So the best way to describe this is to maybe compare it to pessimistic and optimistic locking and show how the escrow locking is at a finer column level. The 2 main aspects of it are that it does locking at a finer level, which is at the column at the field level, and it takes a journal as an intermediary for any changes. Okay, so let's go into a little more detail and go through that. So pessimistic locking, very straightforward, very slow, just because you are blocking. As soon as a transaction takes hold of the data, it's blocking. So very safe, no dirty reads or anything, but you're doing one transaction at a time. It's serial, okay. Optimistic locking, it's allowing other transactions to come in, and so you're getting the concurrency, but it has the potential for older transactions to not be able to complete because newer transactions have come in. And so that longer running earlier transactions, when it comes time to commit, the inventory they need may not be there, and then there's a rollback. So moving on to escrow locking, or the what technically is lock-free reservations, we have this concurrency mechanism where we introduce a journal. And so everything, when an action is taken against data, it's recorded in this journal, and the journal is in charge of, allowing or rejecting those changes. So here we see an update comes in to reduce the inventory, and the journal is reduced. Another one comes in, it's reduced and committed. So the journal says in the first place that it can accept it because it knows the amount's there, and then it commits it, and then it finally flushes it actually to the database. Another update comes in, and there's not enough for it, so it is rejected. There aren't 5 in there, there are only 2, so it's rejected by the journal. And then that older T1 transaction comes in, and it's able to get the reservation that it had made before. It's able to get that inventory because that promise had been made to it. Okay. And so we see this high concurrency, but we're able to not deny the older transactions. And so this is very interesting because it has 3 advantages, really. But the 2 advantages as far as the access, the regular access of the data, are the fact that it can handle hotspots on inventory. So, these fields that are accessed rapidly, that scenario can be handled, but also long-running transactions. As we see here, T1, that if a promise was given out, then it's sustained forever until its commit time. Okay, so the analogy is that it's the shopping cart where you're taking one item, you're not taking when you take one item off the shelf, you're not taking all of that item type. And someone can't come into your cart before you go to the cash register to take the item that you've taken off the shelf. Okay, so it's more optimized that way. And then the third advantage is that this journal that's created can actually be reused in sagas as a journal to auto-compensate, to keep track of changes in the saga and auto-compensate when it comes time to, complete the saga if you have to compensate. So that takes care of that extremely error-prone coding that I mentioned earlier, and that's why it's an amazing feature. So these are the 2 really big aspects. And a third being that it's the fact that it conforms to the LRA standard. So you're using standard annotations, but I'll get into that a bit more on the next slides. But not just standards based, it goes beyond the spec to provide event-driven sagas using the transaction event queue and that transactional messaging I mentioned, but also uses the lock-free reservations for auto compensation. Okay, so very strong Saga coordinator. So just very quickly dipping into the code here, I want to show you, as I say, it uses the standard LRA annotations. And if you're used to JTA or whatever, this is just like, or OTS before it, it's just like the transaction annotation where you're indicating, you're demarcating when the saga will begin and end. And it has all the different transaction attributes and things like that. But there are additional annotations, a number of different convenience annotations, but also annotations that are required for event-driven support with sagas. because the LRA specification actually does not specify message-driven sagas. That's been a discussion and planned, but it's not actually in the specification. So the Oracle database Saga framework is the first to actually provide this event-driven mechanism. And so we've provided this additional annotation response. So there are a couple of response, and then we'll see the equivalent request on the participants. So what we're looking at here is the initiator of the transaction, okay, which is technically a participant as well. It's a special type of participant because it's starting the saga. And so we see the response annotation here. So the initiator will start the saga and send messages to participants, and then the @response method here will receive the responses from those participants so that it can determine whether it should, commit or roll back, complete or compensate, to put it another way. Okay, so this is the initiator. Then we move on to the participants. Again, they are using the LRA spec complete and compensate annotations, but you see that nothing actually needs to be done here, which is another optimization. You can actually, since everything's going on in the database, you can actually avoid even doing the callbacks to your Java application. Okay, if you are using Java, which is supported, of course, as you see here by the Oracle framework. You can also use PL SQL, which is why I mentioned that. So as I mentioned in the last slide, we have the @request annotation. And so that's going to annotate the method that's receiving messages from the initiator of the transaction that we saw in the last slide. So it will process that and then send its response back. Okay. I just wanted to mention very quickly, there is a new workflow product, the Apex workflow in the database, and we've support sagas in that. So in the future, I will show other blogs and videos in more detail, but this just shows the workflow that we've written that introduces a manual step. And in finance and transfers and things like that, this is a fairly common scenario. So this is the same bank transfer saga scenario, but in Apex workflow and using a manual step of requiring a human approval. The only other thing I was going to mention, or I am going to mention to you, is the open telemetry framework that we have here at Oracle. So all of our products are well coordinated from the beginning to the end of an application request. So wherever it's coming from, mobile, web app, going through Kubernetes, and going into the database, we have end-to-end tracking for metrics, logs, and tracing from end to end, as I say, and that includes into the database. So our latest features include actual open telemetry traces being exported from the database. And again, no other database does this. But what's fantastic about that is you can see a trace from your, Kubernetes or whatever you're coming from into the database, as well as database information in one trace, where with any other solution, you need to trace up to the database, take your IDs or whatever, go to the database and look it up and correlate them that way. So we, of course, have OCI, O&M, APM tools that are very intelligent, but also we support all of the open source tools. So as you see here, Grafana, going from right to left, you have a metrics. You might drill down to the metrics into the log. The logs automatically find the open telemetry tracing ID. Here we're using Jaeger. And then you can drill down into Jaeger and see from, as I say, from the front end all the way into the database. So I bring this about because it's so critical. If anyone knows about microservices, this is extremely critical. And then if you're adding the complexity of sagas to know the coordinator calls and all of that, it's good to know that we support this fully with the Saga engine. We designed it from the beginning this way, so you can trace all your microservice, all your Saga activity end to end. Okay. And with that, I will thank you all of these topics are covered in these blogs, and all the features are in the Oracle database. You can grab the free Docker image from this location, or you can use the autonomous database and grab it from that location. And of course, you're always free to contact me with any questions you may have. Thank you so much for your time.